Hey, Southing Airlines Math and History, and we are going to be noticing a new parabola formula. So, we have been taking a look at the formula ax squared plus c. But there's a new formula for a parabola, but it's going to be a different kind of formula. To start out the video, let's see what are the differences and the similarities of these two expressions. Well, what you see here is they do both have an ax squared value, and they both have a c value with the 7s. But the only difference is it has a 4x, or what we're gonna do is we're gonna use it as a bx. Because, get it? Because when you do 2x squared plus 7, we have been taking a look at ax squared plus c, and that only happens when b must equal 0. That's what we have been learning in the past, how to identify them and how to graph them. So, what we're going to do now is, since we have a bx and we have another variable and a coefficient in front of it, we're now going to call it ax squared plus bx plus c. And that is going to be called quadratic standard form. When we were learning about this, we took out the bx. But now, when we learned about ax squared plus c, we can advance toward a higher level of thinking. And now we're bringing back bx. When you have bx, that means that b can be anything, but cannot be 0. Which means b can be 1, 2, 3, 4, so on, or -1, -2, and so on, but it cannot be 0. Get it? It cannot be 0. So, we are going to bring back the quadratic standard form, originally.
Come on now, brothers. My life for us.
So what we're going to be doing next is we're going to be graphing the one without the bx and the one with the bx. And we'll see why they are a bit different. So what you saw in the graph was a little bit strange. Here's what we saw as well. We're going to highlight the first one, orange, and we're going to highlight the second one, blue. And what we saw on the graph was a little bit weird, that when you add the bx into the quadratic standard form, it kind of messes things a bit, because when you have a y-intercept of 2x squared plus 7, let's say that this is the y-intercept, and the parabola kind of looks like this. But when you tried adding the 4x in, or the bx inside the equation or expression, instead of the y-intercept becoming the vertex, remember, the vertex happens when that's at the end of a parabola's curve. It's where the curve is and where it ends. Instead, you found out something that totally looks like this. And instead of having the y-intercept as the vertex, somehow the vertex goes somewhere around here. That happens a lot when you have the letters b and x inserted into a quadratic trinomial. So technically, it moves the entire parabola from one position to another. Not only that, when you try to find the angle of axis, it's going to change too, because when we have been taking a look at the angles of an axis at ax squared plus c, the orange parabola, you would normally find to have the angle of axis right at 0, or your equation is x equals 0, because that is the middle of where the two parts of the parabola fold together, or if you put them in a mirrored version. Instead, when you have a bx inserted, instead of having an x equals 0, you might have an example like x equals -2. So the entire parabola shifts to another point on the graph. So somewhere like this. It will shift it to another point on the graph. Here's an example.
Go.
So that's an example when you have a bx into the quadratic trinomial, it will make the entire parabola move to a new spot and also make your angle of axis move to a different spot as well. And that is what is going to happen when we notice a new parabola formula. Now, next video, we're going to talk about how we can graph these new parabolas when we have a bx in our equation. And we'll also talk about why it happens and how we can discover the vertex if it's not the y-intercept. I hope this video has helped you. Thank you for watching Tapping in Life's Math Industry. Like and subscribe!